Perfect. So Jake, over to you.
Cool. Yeah, so hi everyone. Jake Nickles, based at the School of Geography and Planning at the University of Sheffield, and I'm a research fellow there. I was going to give a quick sort of talk about where I'm from and where I work. I might accelerate that because I don't want to chew up too much time. But just very quickly, there's that photo that you like, Katia. Just about me, I have quite an unconventional background coming into controlled environment agriculture. I actually have a history in food and beverage. I used to work in that industry in New Zealand, so that's where I'm from originally. And I moved to the UK in 2010 and worked for Mitchells and Butlers for a few years, and then had enough of that and decided to set my own pub up in Sheffield, which I did at the Red Deer, which is right in the middle of the University of Sheffield campus, and kind of exposed me to university life, especially through people like the schools of engineering, journalism, and archaeology. I had the pub from 2010 to 2021, but in 2016, as a result of one of those sort of late night pub conversations that kind of results in a lot of interdisciplinary research outputs, I ended up becoming a uh, industry supervisor for a PhD student who was transferring from his master's in archaeology to a PhD in biochemical sciences, which was quite a transition. And that was as a result of talking with a colleague in biosciences and thinking about the history of beer. So we looked at applying molecular techniques like mass spectrometry to archaeological artifacts to understand what organic residues were within those, and whether or not we could actually recreate beers, particularly from the medieval period, before hops were sort of the dominant ingredient in beers, as it were, or ales. Um, During that relationship, I kind of developed a bit of an understanding of how things worked at the university, and a project was knocking around that needed some work, and particularly a business case writing up for it. And so I was offered a chance to take that on as a temporary job, which I did. This project was looking at installing controlled environment agriculture facility or a demonstrator in the Middle East and North Africa. So I went over, did the background research, came back to the UK, obviously submitted the business case, but we ended up applying for institutional links funding and getting just shy of £500,000 to deliver the project. Of course, a project like that needs a project manager, and that was offered to me because of my background and input on it. And so in 2016, I kind of had a chance to step back from my role at the pub, put a manager in place, and I started my career working for the University of Sheffield in CEA. In that particular project, we built a 250 square meter demonstrator at Sohar University, which looked at applying off-the-shelf technologies and coupling them together to tackle some of the harshest growing conditions you might see. So particularly in summer in Sohar, it's extremely dry, sunny, hot. There's no water, fresh water, and there's no soil. So we were applying things like aquaponics and hydroponics, different cooling techniques, desalination, and so on. While I was working on that project, I got to thinking about the other side of things and the less technological application in a controlled environment space. And so at the end of that, I put a couple of grants together with colleagues to look at deployment of low input systems or DIY systems, which resulted in the implementation of an aquaponics system in a orphanage in Kathmandu called Olgapori, and then also a bit closer to home in a low socioeconomic area in Sheffield called Tinsley. We have the infamous position of being one of the first primary schools to be abandoned because of high air pollution, and the site became a community hub space through the council. And so there was an opportunity to take a classroom there and install some hydroponic systems, which I did from scratch, built somewhat poorly by scratch, but DIY, with a view of engaging with the local community on food and food systems, and particularly talking about fresh food and ways that you'd be able to grow products to add to your meals at home in a potentially in an area with potentially little to no access to green space or allotments. So that's a little bit about me. The University of Sheffield, just very quickly, it goes back to 1905. It's a civic university originally funded by penny donations from steel workers at the time. And it sits now, it has 5 faculties with about 28,000 students. So, reasonable size. There's always been an engineering backbone to it, and this has culminated in things like our advanced manufacturing research facilities, which are kind of on the interface of industry and academia and specializing in things like composites and advanced manufacturing techniques. And they work with big companies like Rolls-Royce and McLaren. But in our science faculty, we have one of the world-leading bioscience schools with research around ecology and evolution, molecular microbiology, plants, photosynthesis, and soil interactions, and so on. And then where I'm based is what's called the Institute for Sustainable Food, which is a holistic interdisciplinary research institute which sits across all 5 faculties. And we look at food and food systems from everything from production to supply chains and market systems up to historical context, policy and social inequality as well. And then within our facilities, it's worth mentioning that we have quite a range of CEA relevant technologies at our disposal. So particularly in the microbiology, we have a lot of molecular methods, including a suite of omics, proteomics, metabolomics, genomics, that sort of thing. And then we have 3 CEA sites, one of which is called the Sir David Reed Controlled Environment Facility, which has about 60 state-of-the-art CEA chambers and rooms where we can, simulate extreme environments or real-world conditions anytime in the world, anytime, anywhere in the world. Or we can also incorporate some of our advanced sensing systems like automated phenotyping or multispectral imaging. So I'm here to talk about H3 today, and I think the title of the talk, Charlotte had a little bit of liberty there. There's not too much health on this. I'm just going to talk more about what I've been doing for the last couple of years. But the H3 project itself is one of 4 large consortia projects from a wider program called Transforming the UK Food System, which was a strategic priorities funded program. We secured £6.2 million to get this, and we lead a consortia which includes universities of Leeds and Cambridge, amongst many other stakeholders in industry and NGO spaces as well. And our work in particular, the H3, is a very wide project. So H3 stands for healthy soil, healthy food, healthy people. And this means that the project covers everything from microbial interactions all the way up to policy interventions and picking up other things like dietary interventions, biofortification, regenerative agriculture, and things like work package 2, which is what I've been doing for what I think I've been doing for the last 5 years. And this is really aptly named hybrid hydroponic horticulture. Try saying that 10 times fast. I don't know why we stuck with that name, but it was what we did. But what we wanted to do and what I was really interested in is looking at this low input DIY context and thinking about this in novel contexts. So if you're a farmer working with our regenerative ag work package, you want to start practicing regen ag, there's an economic penalty to that. I wondered if you could deploy a DIY low input system somewhere on your farm to supplement your income while you're doing this, participating in new practices that might have an economic penalty. And I've made it very clear, but the DIY and the low input thing are the key aspects to this. So DIY is to make it accessible. Anyone can build these systems, and ideally using parts that are really easily accessible, so secondhand or repurposed parts, and low input, because as we all know, energy is an issue. We want to have these systems running without any auxiliary heat or light. So to do this, to assess the feasibility, we decided to build 6 polytunnels in 2 sites in South Yorkshire. There's 3 at Wentworth Castle Gardens, which is in Barnsley, about 15 miles away from here, and 3 at Alcalmolly, which is a dairy farm, which is on the peri-urban border with the city. And within each of those 3 polytunnels, there's 2 NFT hydroponic systems with an area of about 32 square meters of growing. So we're looking at a total production area of about 200 square meters, and they're built explicitly out of second-hand scaffold pipes, square line guttering. The sump tanks are IBCs, and the only electric component in the whole system is a pump to circulate the nutrient solution. Speaking of nutrients, we just stuck with what you can buy off the shelf. So we were using a 2-part A+B kind of Vitalink product from the local hydroponic supplier. and we were running probably about 800 liters of nutrient solution through 54 or so channels that were about 2 meters long. So that, depending on planting density, would give us about 500 plants per system. And obviously you've got 12 systems in total. So a total productive capacity of 6,000 plants, or about 1.2 tons of fresh weight per cycle. So not huge by industrial standards, but much larger than you might expect to see in a university context. One thing I should mention here is part of the low input strategy was no pest or disease control, apart from a very fine insect mesh, which we applied to all the openings of the sites. So for the last 2 years, 2024 and 2025, we ran 2 distinct trials. In 2024, we really wanted to get an understanding of what plants grew best when, and so we grew 9 different crops, ranging from leafy greens through to herbs and brassicas, in a randomized block trials, all simultaneously, all the way from February through to December. And because it was continuous, there was a slight condition in that the nutrient solution was never ever stopped and replenished. We continuously ran this all year long. So this would be through a standard procedure of maintaining a preferable EC and pH just by topping up water or nutrient concentrates, or amending pH using phosphoric acid or hydrogen peroxide. And then we also were very careful about monitoring some of the environmental conditions. So we had 50 different units that were measuring light, humidity, and temperature across all 6 polytunnels. You can see here there's a little chart which I'm happy to share with you and for you to share, but as part of a thesis that's just gone in, so please don't publish it anywhere publicly. But this is from our PhD student, Toby Evans, who was able to model crop growth during the course of that 2024 period, and able to factor in things like shocks to the system. And I mentioned that because I mentioned pathogen infestation. At one point, we did have an outbreak of downy mildew, which affected yields. And he was able to capture that in his model, which is quite cool. And this is the sort of output that he's come up with here. What's interesting is the yields are good. With a low input system that's been run pretty rough and ready, we're sitting at about 35 to 40 kilograms per meter per year, which if you compare that to in-field, about 6 kgs, or a greenhouse but running with soil might be about 28 kgs. We're out competing both of those. And at times we might even tickle the total controlled environment agriculture yields at that 40 to 80 range. So we were happy with that. It gave us some really good insight into productivity during the course of the year. One of the other things that I mentioned pathogens about, something that was a concern to me because I'm thinking about real world application, is human pathogens. And this is particularly relevant at the Alcal Moly site, which is situated very close proximity to a slurry tank. And so I wanted to make sure that all of our products were safe that we were producing. And so we did routine screening for human pathogens using the FSA's guidelines. And you can see here it's actually pretty good. The red line is the sort of undesirable limit, which is set by UK HSA, but it's not actually the legal maximum limit. And at all points we're under that, except for one sampling occasion, which I've highlighted here. Things like E. coli and Salmonella and Listeria were not detected at all, and E. coli and Staphylococcus were pretty much below level of detection, except for that one thing there, which kind of indicates that there's some work to be done in the hygiene space. And then building on from the crop yield work, Toby also was collecting retail values for similar or the same products during the course of the year. And so we're able to generate a rough and ready estimate of income based on all of our costs and what we can anticipate to sell. So you can see here, our capital expenditure is actually quite expensive. £330 per square meter for polytunnel is a lot, but this is an artifact of commissioning and having the polytunnels built during lockdown when there was a steel shortage, a labor shortage, in fact, just a polytunnel shortage in general. So that's a nuisance number, but it's there. Operating expenditure is very low, £95 per meter per year, with the bulk of that, about 90%, being electricity just to run these pumps. So there's some interesting information to kind of deep dive into there. And then we did a sales forecast factoring in waste and things like that. And we were predicting an income somewhere around 12 to 58 grand. There is a big hole in that data though, and that is labor. And so that's what we did in 2025. We looked at sort of resource use optimization and monitoring labor as closely as we can. So we had a very granular tracking system for labor. And we changed up how we were growing. So rather than having this kind of non-representative 9 cultivars on constant rotation, we did monocrops that we grew to maturity, harvested, shut the system down, cleaned it, started again. So we could get a much better handle on what sort of labor we can expect and also what sort of electricity we could expect to be using in the systems as well. Interestingly, if you look at this data, in fact, I might move on to the next slide. I pulled out here the top 5 most impactful things by percentage on each site, and you'll notice that transport or driving is a significant factor there. It's about 18% of the total labor. And this is an artifact from having 2 polytunnels 15 miles away from each other with one person working at both of them. So something that it's not very realistic, but something to consider. You know, if you've got a workforce traveling backwards and forwards, it can have quite a substantial effect on your on other things as well, perhaps your what is it, phase 3 carbon emissions and stuff like that. Cleaning is an interesting thing for us and something that was kind of unexpected, but cleaning is highly problematic in terms of labor, especially in our situation in which we weren't able to clean at Wentworth Castle Gardens because of space limitations. So part of that transport issue is transferring channels back to Alcalmolly for washing, but it certainly highlights an opportunity for businesses looking to get into CEA that might not be interested in growing if you can develop cleaning products. And then some other things that have impacted us that probably don't really align with the real world are things like monitoring, which, you know, we're still trying to maintain scientific rigor here. So monitoring was much higher than you might expect in a real world context. And also some of it can be automated, you know, pH and EC meters can be in line. But interestingly, with the minimum wage applied, we're looking at a 17 grand labor bill there for a year's worth of work, which is doable. So overall, we're kind of starting to see feasibility across these systems. Not fantastic feasibility, but it's feasible, which is a good place to start. In terms of yields, this is just a really rough diagram kind of explaining what yields were looking like, and this really matches and validates what Toby's modeling work looks like, which is really considering what plants grow best when, and something that you should keep in mind if you're setting out for new. The dotted line on this, the yield metrics are based on kilograms per meter per day here, and the dotted line represents that target of 35 kilograms per meter per year that I'm aiming for. So you can see a lot of the time stuff was well over that. There are some anomalies here, in particular when you think about herbs like coriander. They're never going to hit those huge quantities, but they have added value because you know they're products that are worth a lot more per kilogram than, say, leafy greens. And then I mentioned energy. Unfortunately, we didn't have. I mean, we had a year, so we had a lot of time, but because we were running multiple growth cycles, we weren't able to monitor to a robust enough level for us to make any scientific inferences. But I think what's interesting here is if you look at the bottom of the chart, this is different power regimes, which we were looking to obviously reduce our input on power. In 2024, we ran 24/7 on our NFT systems. The pump was always running. In 2025, we ran different regimes. Some were 24 hours, some were 12 hours, so maybe just during the day. Others were different levels of pulsing, so you might run for 15 minutes a day, every 2 hours, and so on and so forth. So down the bottom kind of shows you the input of how many hours the pump was running, and then you can kind of see what mass is produced. And what's interesting about these diagrams, hopefully you can see my mouse, but we start to see a level here. So, you know, it makes sense. There's an optimum to be looking at here. How low can you go in terms of fertigation strategy to get a yield that is meaningful for you, and something I would really like to pursue in greater detail. What is interesting to me is that compared to last year, we've saved at least 50% of the energy that we used the year before, and that's including the 24-hour regimes at times. So, you know, there are savings to be had just from very simple changes to your system. Yeah, so learnings from H3 and particularly work package 2, there's some very, very interesting thought experiments around things like format and processing. So we considered looking at, and this is a significant part of Toby's PhD thesis, is looking at whether or not loose leaf or whole head lettuce presented better value. And on the whole, loose leaf bagged certainly does represent better value, but there are some serious considerations when you start factoring in that processing step. In particular, if you're bagging like a loose leaf salad, then you really do trigger things like FSA regulations, which is not something you necessarily see in a whole head product. And obviously there are other cost influences like that with that. So things like washing, bagging, labeling, and so on and so forth. The planning thing is also really interesting, and I can't wait for Toby's work to start being published, because looking at growth models during the course of the year with next to no input system in the UK context really does start to tease out what plants prefer in terms of light and heat, and there is definitely advantages to having certain crops at certain times of the year, which is something that we don't tend to see. Particularly in the CEA space, it is usually just one crop or a type of crop that grows at very similar conditions all the time. But if you were to maybe tailor your system, you could probably reduce your input and exploit plant growth parameters in that way. The energy use efficiency, I've mentioned already, I'm really interested to dig into particularly the fertigation strategy a bit further. And I think this is really important when you consider other formats of hydroponics systems. So, for example, aeroponics or fogponics, which we know use less water, but I wonder about the energy use efficiency on that. And then, of course, space is another thing that we didn't really get into in Work Package 2. Early on in the program, we did a small validation trial at our facilities at the university. And I said small, I think it was 16 square meters growing space. And on that, we actually did a stacked system. So still the same conditions, no additional heat or light, but we put a second layer on over the base layer, and we were able to increase output of the system by 50% at the right time of year. So that's an interesting thing that I think we should really be digging into a little bit further, because if you get the spacing right in your plants, you're basically getting free growth from the sun, obviously, but it's make hay while the sun shines, as it were, literally. And then I think glassing, particularly from an academic context to think about, is demand. I mean, if we were producing 6,000 heads of lettuce a cycle, that's a lot for us, and I think it's unlikely that we would sell those to direct consumers or through what I would call a near direct consumer business, so like a local fruit and veg shop. Now that has implications, because obviously if you're selling direct to consumer or to a local business, you might be able to charge more, which is great. But if you have 6,000 heads of lettuce, you need to move them in time. And I'm really interested to think about, okay, well, when you start scaling, what are the cost implications to that? Obviously, a supplier wants to buy more off you. The more they buy, they expect a greater discount. And what does that really mean? So that's a space I'd quite like to go down at a later point. And I put a slide in just for you, Mark, which I don't know if you saw this last time, but just I'm really curious about what's happening with vertical farming at the moment, and deep diving the failures that we've been seeing, and I've been doing quite a bit of research on this. I think I mentioned this in the last presentation I gave where you were there, Mark. But if you just take a little plot of energy prices and compare that to the number of big failures in vertical farming over the last 10 years, there's a very direct correlation there. And so I can't help but stress this enough. And we've already said this as a group, like energy is a big thing. We need to think about it. Being energy efficient is one thing, but if you can take some kind of learnings away from projects like what we've done and maybe even step significantly away from it, then there are real benefits to be had there. Oh yeah, and then the last thing I was going to talk about today, which is kind of bookends my talk, but we are hosting the Northern Controlled Environment Symposium here in Sheffield on March 25th, which coincides with the UKUAT AGM. I think pretty much most people on this call have already got tickets, so you already know about it. But we're hosting speakers from other northern universities to kind of focus in on and showcase what research is happening in the north of England. And we'll have these talks which are kind of structured around materials and then later on in the day more application. And if you need to know more about that or need to register, then I've put a QR code there, but you can also email me if you're having any problems with that. And I think that's about it. Yeah, thanks very much for listening.